Hello, peoples of the SQL class or anyone else that has found their way to this video. This morning I was talking with Bill and I was mentioning how I haven't used the Microsoft suite of SQL products very much before, and then I got to talking about what I normally use. So for example, if we're using Windows, as you guys all know, you use the, Microsoft 2019 Visual Studio Express or whatever the heck it's called. That's not what it's called. Something like that. Something ridiculous. Microsoft has to put their name on everything. But anyways, you're using some Microsoft product to set up the databases. It works fine. But I was mentioning how I normally do it when I'm running on Linux. I normally use Docker. And it's just kind of a fun thing, and so I wanted to show it off. If you don't care about what Docker is, that's what this whole video is going to be about. So if you don't care what Docker is, I'll save you the time, and you can just leave now. But Docker, it's pretty nifty. So what it is if you have experiences using virtual machines before, I would assume you guys do. I think we used them in the networking class. Virtual machines, you can set up. We could launch this one because it's really lightweight. You can launch display output not detected. Don't you have a display? Whatever. You can run operating systems inside other operating systems. If we capture. So here, we have this is tiny Linux, so it's Linux with mostly everything stripped out of it, just enough to function more or less, which can be useful for some cases. Anyways, I have an instance of it as a virtual machine just for fun. This, in the olden days, I've been told, was how you'd run lots of web services on a single machine, which is probably, I don't know how much experience you guys have with web services. But anyways, you would run them all on virtual machines, which is fine and all, except that it's very resource intensive. Obviously, that isn't very resource intensive because it's tiny Linux, but you can't really do much on tiny Linux. If you were to use an actual, you'd most likely, if you're setting up websites and stuff, you're using Linux. If you're insane and you're using Windows, that would just take a ludicrous amount of resources to run multiple instances of Windows for each service. You maybe have the front end and in a VM by itself, and then you have the back end over in a VM somewhere that has like databases and stuff, because it should be kind of a separation of concerns. It would take an insane amount of CPU power to be running multiple instances of an operating system all in one device. So what was devised was something called Docker. You can think of it as running virtual machines, because that effectively, to the user as the developer is the user in this case. To the developer, it feels very similar server to using virtual machines, but it's way easier on system resources. I was running the Windows VM earlier, and it put my CPU up to like 70% usage and like 12 gigabytes of RAM, which is kind of insane. Docker, you barely notice it's running, assuming it's just idling. Obviously, like anything, if it's using CPU, it's using CPU. It doesn't. It's not some magical special sauce that just like, oh, free CPU power, because that doesn't exist. Otherwise, that'd just be some sort of black magic, just like, ooh, free CPU. Anyways, so Docker, what it is you start off with a base image, Docker Ubuntu. You start off with an image, and you can even start off with an image like this, where it's just Ubuntu. So you're effectively starting off with an entire operating system, but it's still lighter on system resources because it's not emulating hardware. It's just kind of passing it through to the hardware that's already there. So a lot of things are built off like Ubuntu or Debian, which is just Linux distributions. And as you can see here on, this is my local server, I have 4 different images running. And so, anyways, to tie it back into databases, what can be really useful here is if we were to look at image list. Here's a list of images that I've installed on my desktop. And if we scroll, we can see here I have a MySQL image, I have a SQL Server image, I have a Redis server, I have a Postgres server. And so these are all installed, and I didn't have to actually install it locally on my machine. I do have SQL installed on my machine, but that's entirely irrelevant. If we were to look at like Postgres SQL or whatever the command is, I don't know what the command is because I've never used it. I don't have it installed, but we can install it in a Docker image. And where that becomes important is it allows us to create a reproducible environment very quickly. And so why we'd want to do that, I don't think I have it installed anymore or open, is if we were to go to like this project on my GitHub, you can look at it. It's public if you want. I'm setting up some authentication for a Rust web framework. And to do authentication, obviously you need accounts and you need some way to hold the login state. And so I'm using a Postgres server and a Redis server to do that. And if I wanted to, so let's say I was working on my laptop and I wanted to work on this project, I would have to, go off and install Redis and install Postgres and make sure that's all working, and it'd be a pain. And then I go over to my desktop and now I gotta make sure I installed everything the same. And it's just a big pain because it's not quickly reproducible. What Docker allows you to do is with Docker Compose, which is kind of like a subcomponent of Docker, you can write these YAML files. I don't know if people say YML or like YAML. I've always heard it just YAML. You can just define, hey, I want the image of Postgres and the image of Redis, and then we're going to, set up some parameters for it. You put it all in this YML file. I guess YAML, or you can do it with just the YML. And then what you just do is you use sudo docker compose up, probably with a D flag to detach. You just run that command, and you'd be off to the races. It would pull these two images from the internet, load them up. Then we could use some command like docker IP and then type in the image. It's a little like short hash, one of these like 10-character hashes. I don't know if it's an actual hash or what it is. Type in one of those, get the IP, and then you're off to the races. Which, speaking of which, if you do end up using Docker a lot, I can post this in the video description. It's just a quick little script that you can put in somewhere in path, because presumably you guys know about path. Path on Linux is where your system tries to find commands. So if you can write any old script. If you put it in path, then you just type it, on the command line. It searches through all these folders to find it. So a common one you can see, local bin. So if we cd into local bin, these are meant for you to just put things. So for example, I have a bell script, and we can see it's just PA play and then a sound. Anyways, that's how you set up some custom scripts if you want. But I have a script that, I didn't write it. It's from Stack Overflow somewhere, but who actually gives credit? And it just will find the IP address of a Docker image that you send it, because by default, Docker images. So if we go PS, let's say we grab this. If we want to, you have to scroll through all of this mess to find the IP address, and no, that would be painful. So you just go Docker IP, put in the image. Do I not have Docker IP? I might not have Docker IP on this machine. And then it would just return the IP address. Makes your life a lot easier. Because we know that by default, our address, most likely, depending on your network, whatnot, it's going to be a 192.168 address. Obviously, you have the 10 block that is free for local use. 127 is obviously free for local use. And 172 is free for local use. Docker, by default, it seems to always just take a 172 address. And so then these are the IP addresses of those Docker containers, and you can do standard networking stuff like SSH into them, whatnot. And so that's really useful for setting up databases. So if all you're here is for databases, that's kind of the end of this. But I would like to show you some other fancy stuff you can do with them, because this is where it kind of gets exciting. So if we were to go into, let's say, my Jellyfin. I don't know if you guys know what Jellyfin is. Basically what it is it's a local streaming service. So you can have downloaded content, and then you can watch it, as if it were a streaming service, but it's installed locally. And it's pretty nifty. And so it's like, whoa,
room with her.
22 Jump Street, whatnot. Kind of a funny movie. And you can just install it locally. It's all fine and dandy. And they have a Docker image. So if we look at the folder where I have the Docker image, let's make this bigger. You can see what's happening here. We have a service. Let's not edit this. We have a service named Jellyfin with the image Jellyfin, and then so this is the organization name. This is the image name. This is the version flag. So for Jellyfin, they're the organization and the image is the same name. So it's not a great example. And so what will happen is when you're on Docker Compose in this directory, it will pull this image, and then it will, another cool thing, it will pass volumes. So these volumes all exist on the host machine under, this path. They all exist under this path. So home Oliver Jellyfin config, or home Oliver RAID TV. RAID is, I think we did something of RAID in one of the classes, but it just allows you to store data in a way that if a drive goes down, you don't end up losing actual data from like mirroring and striping across different drives. But this, I'm not going to talk about RAID because it's annoying to set up. And then it maps it into the folder media on the host machine. So, or not host machine, from the virtualized, not really virtualized, in the container. So from the container's perspective, it thinks that there is a file in media, which obviously doesn't exist in a normal Linux OS. But it just maps this folder to that, which if we server, if we cd to home Oliver RAID TV, we have movies and shows, and then it goes down and you have a bunch of different files down there, and it maps it into the container, which is very nifty. So you can map file systems into the container, which is very useful for persistence and stuff, because if you don't intentionally persist files in Docker containers, they won't persist. When you restart it, then you're like, oh crap, where did the cache folder go? Where did the configs go? So obviously putting caches and configs on the host machine and passing them in, very useful. You can also do a fancy thing in here under resources. We can pass a GPU. So we can pass full-on resources into it. Normally, a Docker container just has access to the CPU, but we can pass a full-on GPU. So we can show that if we were to go Nvidia. So like this machine has a GTX 1070 in it, which is it's not too bad of a graphics card. It is Nvidia, which is a bit unfortunate. My host machine has an RX 5700, which is a very tasty graphics card because it's AMD. Linux works better with AMD. But anyways, we have an Nvidia card on this server. So in order to pass it forward, we deploy with resources and we reserve a device with the capabilities of a GPU. And so if we were to look at Nvidia SMI, which shows the running processes of an Nvidia card, it's kind of like a task manager for Nvidia from the command line. We can see no running processes found. Even if we were to start streaming this, we can just mute that. We jump around. Nothing is running. That's because it's no, we don't want to repeat it. It's running at auto quality, which since it's on a local network is just direct. Let's say we're on a low bandwidth network and we want to watch it at 320p. Obviously, lot quality, 320p. And now we can see Nvidia SMI that FFmpeg is re-encoding the video to then send out as it's being streamed, so actively re-encoding. It's pretty nifty. Some other cool things you can pass through, since Linux shows USB devices as files, we can let's see where we're at. We can send USB devices into systems. So right here we have Octoprint, which is, what the heck? I don't want to upload anything. Excuse me. Octoprint allows you to access 3D printers over a network, which is very useful. That way you can, and it controls the actual printing. So I can send stuff over to the server to 3D print, and then I can do something that's CPU intensive on my local machine. I can restart my local machine, and the 3D printer continues going because the server is on the whole time. But obviously you need a USB connection to a 3D printer for it to work. And since it's in a Docker, the Octoprint, which is what's the image that's running, is running in a Docker container under devices, similar to the last time when we were passing in a GPU. Here we pass in dev, and we pass in the USB machine, which is very tasty. So then we can see that we pass it in under the same name because there's no reason to rename it, TTY ACM 0. And under the connection, we can see it's connected to TTY ACM 0. And you can see right here, maybe you can't, depending on how small of a screen you're looking at, we have the temperature readouts from the 3D printer. One last thing to look at. So we can pass in USB devices, we can pass through hardware components, we can pass through files. One last thing to look at, which is tasty, is this ports section. So you see how internally, how do I want to say this? In similar fashion to how we have, the host machine, and then the then a colon, and then the container path. So right here, this path is on the host, this path is inside the container, this device is on the host, this device is in the container, just on what side of the colon. We can also do the same thing with ports. So this port is on the host, this port's on the container. So for example, I have 2 images running on this server, not Jellyfin, file browser. So this is more or less just a file explorer that is running. My throat's getting dry. A file explorer that's use access over a web interface and Octoprint we already looked at. By default, if we were to go sudo docker ps, that's not the password. That's not the password either. There we go. We're to make this smaller because this terminal doesn't have text wrapping. We would see that Octoprint and File Browser, by default, they both use port 80, which, as you most likely know, that's the default port for a web server running over HTTP. Since I'm running everything local, I don't have any certs because that'd be kind of odd. Like, oh, let's encrypt it as we go over the local network. I'm like, whatever. It's the local network. I trust. I trust it. So port 80 is the default for HTTP. HTTPS is, of course, 443. But both File Browser and Octoprint wish to use port 80 by default. Most likely they have a config somewhere where you could change it. But let's say they didn't have a config and they both needed to use port 80. Well, obviously you can't bind multiple services to port 80 because if we go to an IP address at port 80, only one service can exist there. You can't have multiple things. So inside Docker, what we can do though is we can rebind port 80 to actually be port 90. So this is in the Octoprint Docker. We can see up here we have the local IP address and then port 90, which internally it rebinds port 90 to port 80. So Octoprint thinks it's on port 80, it's all happy. File Browser thinks it's on port 80, it's all happy. But actually File Browser's on 8080 and Octoprint's on port 90. So pretty cool. You can rebind ports and you can get rid of port conflicts quite easily with Docker. It's very, very nice. One other thing to note is that if you're using Docker in more of like a production environment, as you may or may not know, if you're setting up a domain, there's no place for a what do you want to call it? A port as you're setting up a domain. You have your domain, and it can go to an IP address, and that's it. You don't get to set up ports. So what if you want multiple services running on one server? What you do then is, let's say we have it running in Docker. Let's pretend we were running these both in Docker, and we have them reboot to port 80 or port 90 and port 80. What we could do is, we'll go with a real example of my website. One of the services is running on port 3000. So we could have them just import the, TLD and then put colon and a port number after it. But that looks kind of nasty. So instead, what you can do is utilizing the power of subdomains and nginx. So I think we did a reverse proxy in one of the classes, so you guys might know about reverse proxies. They're pretty tasty. If you don't, you should look it up. They're very cool. So if I were to stop getting in my way, if we were to SSH into my website, and then cd into Etsy and nginx sites available, vim git. So we can see here we're on my website with the git subdomain, right? It's quite nifty. I use nifty a lot, I guess. All right. So git subdomain, but internally it's running on port 3000, because if we were to go to oliveratkinson.net port 3000, it gets us to the same place. However, you can see this is HTTPS. This is only HTTP. We get us a nice icon. Oh, it's insecure. What happens internally, since it's technically on port 3000, is internally with nginx as a reverse proxy, you can be like, hey, nginx, listen for when a request comes in on the server name of git dot, then I don't want to delete things. Holy balls. You have, your domain with a subdomain git, and then, just go ahead and proxy that over to the local host servers that's running on port 3000. Easy as that. It forwards it. Everything down here is mostly generated stuff. That's all. It's all, what do you call it? SSL keys for HTTPS. So you get the nice little lock icon on your website. It's pretty nifty. You can forward stuff. So it's kind of a weird chain. Originally, the service is running on port 80. Using Docker, you mask it to be port 3000. Then using nginx, you mask that to be port 80 again, just to get around the fact that you can't bind multiple things to port 80. So anyways, I think that's most of everything I wanted to look at. If you want to take a look at the command for finding Docker IPs really easy, I might link this. It's to the Git repository that's on my website. I didn't write this. Don't get the idea that I wrote this. This is stolen straight from Stack Overflow, more or less. I just made it into a script. You could just wget this. I don't know how people, wget this into your. I would just cd into local bin and then wget. You go to raw and then you go like that, and then it would download it, and then it would put it Docker IP. You could put it in your just anywhere that's on path, as I mentioned before. So that's pretty much all That's all I wanted to talk about in relations to Docker. It's pretty nifty. You should learn it. Docker plus reverse proxies is a lot of fun. Have a look at it. Yeah, that's all. Have a good day.